Use TFTP, Flash, and USB to manage configuration files. Topology. Use router 2321, switch 2960, PCA. PCA, switch S1, R1. And connect using copper straight-through cable, Ethernet 05 to gigabit 001, Ethernet 06 to Ethernet on PCA. Router will be TFTP client. Switch TFTP client, and server PCA will be TFTP server. Addressing table, R1 gigabit interface, IP address 192.168.1, subnet mask 24, S1 VLAN interface 192.168.1.11, subnet mask 24, default gateway 192.168.1.1, PCA network interface card 192.168.1.3, subnet mask 24, default gateway 192.168.1.1. Cisco networking devices are often upgraded or swapped out for a number of reasons. It is important to maintain backups of the latest device configuration, as well as a history of configuration changes. A TFTP server is often used to backup configuration files and iOS images in production networks. A TFTP server is a centralized and secure method used to store the backup copies of the files and restore them as necessary. Using a centralized TFTP server, you can backup files from many different Cisco devices. In addition to a TFTP server, most of the current Cisco routers can backup and restore files locally from compact flash memory or USB flash drive. The compact flash is a removable memory module that has replaced the limited internal flash memory of earlier router models. The iOS image for the router resides in the compact flash memory, and the router uses this iOS image for the boot process. With larger size of compact flash memory, additional files can be stored for backup purposes. A removable USB flash drive can also be used for backup purposes. You will use TFTP server software to backup the Cisco device running configuration to the TFTP server. You can edit the file using a text editor and copy a new configuration back to a Cisco device. Ensure that the routers and switches have been erased and have no startup configurations. Required resources: one router 4221, in my case 4321, one switch 2960, one switch 2960, one PC, console cables, Ethernet cables, USB drive. Build the network and configure basic device settings. Cable the network shown in the topology. Ready. Configure basic settings for the router. Okay, make the console connection between PCA and router R1. You can use a console cable, this light blue cable, console cable, to connect RS-232 on PCA to connect the console port on the router. But you can use another option. I will remove this. You can use the USB cable, this purple cable, and connect from USB port to the USB console interface on the router. I repeat, USB console. Okay. Assign a device name. Okay, go to PCA and desktop terminal. Okay. Would you like to enter initial configuration dialog? No. Enter. This is the prompt. Okay. Hostname. Enable. Configure terminal. Hostname R1. Disable DNS lookup. No IP domain lookup. Class is the privileged exec encrypted password. Enable secret class. Okay, enable secret class. Cisco as the console password and enable logging. Line console 0 password Cisco login. Cisco as the BTY password and enable logging. Line BTY 0 to 15 password Cisco login. Exit and encrypt plain text passwords service password dash encryption. Create a banner that warns anyone accessing the device that unauthorized access is prohibited. Banner message of the day: unauthorized access is prohibited. Unauthorized. Enter. Configure interfaces. Okay, this is the router and configure R1 gigabit 001. Interface gigabit 001. And set the IP address 192.168.1.1, subnet mask 24, and no shutdown to enable the interface. Okay, interface gigabit 001, change it, state to app, line protocol, change it, state to app. Save the running configuration to the startup configuration, and copy running config to startup dash config. Enter, confirm, enter, very good, okay. Configure basic settings for the switch, assign a device name. Okay, the switch does not have a USB console, so I will use the light blue console cable from RS-232 on PCA to console port on S1. Okay, and remove this the console connection to the router. Okay, and go to PCA, close the terminal, open again terminal. Okay, enter. This is the prompt of the switch. Device name, enable configure terminal, host name S1. Disable DNS lookup, no IP domain lookup. Assign class is the privileged exec encrypted password, enable secret class. Cisco as the console password and enable login, line console 0 password Cisco login. Cisco as the BTY password and enable login, line BTY 0 to 15 password Cisco login. Encrypt plaintext passwords and configure terminal. On global configuration mode, service password dash encryption. Create banner message of the day, unauthorized access is prohibited. Enter. Shut down all unused interfaces. I'm using interface I'm using interface 6 and interface number 5, 6 and 5. Okay, 6 and 5. So On terminal on PCA, shut down any other interfaces, interface range, facet 1 to 4, comma, facet from 01 to 4 and from 5 and 6 in use from 7 to 24 and gigabit 01 and 02. Shut down. Okay, exit. Configure interface VLAN 1. Okay, this interface VLAN 1 IP address 192.168.111.255.255.0 and not shut down to enable the interface and exit. And don't forget the default gateway IP, default gateway 192.168.1.1. Save the running configuration to the startup configuration file and copy running config to startup-config. Enter to confirm, and okay, very good. Verify connectivity from PCA. Ping from PCA to S1. Okay, and close terminal. This is PCA, and use command prompt. Ping switch, ping to the switch 192.168.111. Okay, request timeout because you need to configure this PC. This PC does not have IP address, IP config, no IP address, and should be 192.168.1.3. 192.168.1.3, subnet mask 24, default gateway 192.168.1.1. Okay, and command prompt and ping from PCA to S1. PCA ping to S1. S1 IP address is 11. Success. Ping from PCA to R1. R1 is 192.168.1.1. Success. If the pings are not successful, troubleshoot. Use TFTP to backup and restore the switch running configuration. Verify the connectivity to switch S1 from PCA. Okay, success. The TFTP application uses the UDP layer 4 transport protocol, which is encapsulated in an IP packet. For the TFTP file transfers to function, there must be layer 1 and 2, Ethernet in this case, and layer 3 IP connectivity between the TFTP client and TFTP server. The LAN topology in this lab uses only Ethernet at layers 1 and 2. However, TFTP transfers can also be accomplished over WAN links that use other layer 1 physical links and layer 2 protocols, as long as there is IP connectivity between the client and server, as demonstrated by ping. The TFTP transfer can take place. If the pings are not successful, troubleshoot. A common misconception is that you can TFTP a file over the console connection. This is not the case because the console connection does not use IP. The TFTP transfer can be initiated from the client device, router or switch using the console connection, but there must be IP connectivity between the client and server for the file transfer to take place. Start the TFTP server. Start the TFTP program on PCA. PCA does not have the TFTP service. A server choose a server, and the server can make the server has the TFTP service. Okay, so this can be PCA TFTP. Okay, the server has the TFTP server, the TFTP service. Okay, and the service is on. By default, is on. And set an IP address to the TFTP server. Connect this cable to fast Ethernet 0 and set an IP address to the server. Go to desktop 192.168.1.3. Subnet mask 24 and default gateway 192.168.1.1. Okay, and PCA will be used only for console connections, and this server for Ethernet connection and TFTP service. Explore the copy command on Cisco device. Console into switch S1. Okay, console into switch S1. And from privilege exec mode prompt, enter copy and question mark. Okay, close the command prompt on PCA and go to terminal. Okay, enter. This is the privilege exec mode. Copy and question mark. Okay. To display the options for source or from location and other available copy options. You can specify flash or flash 0 as the source. However, if you simply provide a file name as the source, flash 0 is assumed and is the default. Note that the running is also an option for the source location. Okay, the options are flash, running, startup config, TFTP, SCP, FTP. Use the mark question to display the destination options after a source file location is chosen. The flash file system from S1 is the source file system in this example. Okay, copy, flash the source, and mark question to view the options for the destination. Copy from flash column and mark question. Okay, and the options are the destination can be TFTP, running, configuration, SCP, startup configuration, or TFTP. Transfer the running config file from switch S1 to TFTP server on PCA. From the privilege exec mode on the switch, enter the copy running config to TFTP command. Provide the remote host address of the TFTP server, PCA 192.168.1.3. Press enter to accept the default destination file name, s1-confg, or provide your own file. The exclamation marks indicate the transfer process is in progress and is successful. Okay, use copy the source running config, and the destination will be TFTP column, TFTP server. Source is running config and destination TFTP server. Enter address of the server of the remote host 192.168.1.3. Destination file name. Use this is the default or provide your own file name. For example, I will use this as one-runconf. Okay, I will use a custom name. Enter. Okay, timeout. Okay, try again. copy from running config to TFTP server, address or name of the host 192.168.1.3. Destination file name, use your custom name as one run conf. Timeout again. Review the IP address of the server 192.168.1.3. Subnet mask 24. Default gateway. Very good. On command prompt ipconfig 192.168.1.3. Ping the switch 192.168.1.11. Success. Okay, from switch S1, ping the server 192.168.1.3. Success, and now transfer copy running config to TFTP IP address 192.168.1.3. Destination file name S1 run-conf. Enter. Okay, success. Okay, 1560 bytes copied. Okay, these exclamation marks indicate the transfer process is in progress and is successful. If you don't have permission to write to the current directory that is used by the TFTP server, the following error message displays: error opening, permission denied. Check the directory on the TFTP server, usually the default directory for the TFTP server software, to verify that the file was transferred successfully. Your TFTP server may have a dialog for this. Okay, how to verify? Go to PCA, the TFTP server, to this server, go to services and go to TFTP. And here you can see S1 run conf. And this is the file S1 run conf on the TFTP server directory. Create a modified switch running configuration file. The saved running configuration file S1 run conf, this file S1 run conf, can also be restored to the switch by using copy command from the switch. The original or modified version of the file can be copied to the flash file system of the switch. Navigate to the TFTP directory on PCA by using the file system of PCA. And then locate the S1 runconf file. Open this file using a text editor program such as WordPad. With the file open, locate hostname S1 and replace S1 with switch1. Delete all the self-generated crypto keys as necessary. A sample of the keys is displayed below. These keys are not exportable and can cause errors while updating the running configuration. Okay. These are the crypto keys. This is the file on the server. I cannot modify this file. And go to desktop and go to command prompt, then dir to show the files, and there is only one file. Okay, and there is only one file, sample file .txt. Okay, and go and close this and go to text editor. File open, and there is only one file, sample file. Okay, and I cannot modify this file, but don't worry. And save this file as a plain text file with a new file name. Okay, skip this because I cannot do this. If your TFTP software has the option, use it to show the contents of its directory to verify that the file is present. Copy the modified running configuration file from the TFTP server to switch S1. From the privileged exec mode on the switch, enter the copy TFTP running config command. Provide the remote host address of the TFTP server 192.168.1.3. Enter the new file name, and the exclamation mark indicates that the transfer process is in progress and is successful. Okay, copy from TFTP the source to running configuration the destination. Okay, S1 the console connection. Enter, password is Cisco. Enable password class. Copy from TFTP server column to TFTP is the source and running config the destination. Enter. Address of the remote host 192.168.1.3. Source file name. Review the source file name on the server S1 runconf. Okay, case sensitive S1-run-conf. Enter. Destination file name running config. Okay, use the default. Enter. Okay, very good. Exclamation mark. Success. Okay. Enter. And after the transfer has completed, the prompt has changed from S1 to switch S1. Okay. Okay, before my hostname was S1, and now my hostname is still S1 because I was not able to modify the file on the server. Okay, I cannot modify this file. Okay, and enter the show running config command to examine running configuration file. Show running config. Show running config. Okay, the hostname, interface VLAN 1 IP address, default gateway, passwords on lines, the enable secret passwords, no IP domain lookup, unused interfaces, shutdown. This procedure merges the running config from the TFTP server with the current running config in the switch or router. If changes were made to the current running config, the commands in the TFTP copy are added. Alternatively, if the same command is issued, it updates the corresponding command in the switch or router current running configuration. If you want to completely replace the current running config with the one from the TFTP server, you must erase the switch startup config and reload the device. You will then need to configure the VLAN 1 management address. So there is IP connectivity between the TFTP server and the switch or router. Use TFTP to backup and restore the router running configuration. The backup and restore procedure from part 3 can also be performed with a router. In part 4, the running configuration file will be backed up and restored using a TFTP server. Verify connectivity to router R1 from PCA. If the pings are not successful, troubleshoot. Okay, change the console to the router R1 console. Go to PCA, close the terminal, and open again terminal. Okay. Enter. Password is Cisco. Enable password class. Okay, and you are on the prompt on router R1, but from PCA, desktop command prompt ping to the router is 192.168.1.1. Success. Transfer the running configuration from the router R1 to TFTP server on PCA. From privileged exec mode on R1, enter copy running config TFTP command, provide the remote host address of the TFTP server 192.168.1.3, and accept the default file name. Verify that the file has been transferred to the TFTP server. Okay, go to console on PCA and copy running config to TFTP column. Enter. Address or name of the remote host 192.168.1.3. This is the TFTP server address. Destination file name, use the default r1-comg. Enter. Okay. Exclamation marks. Success. And okay. Okay. Verify. Go to the server and go to services. Okay. And go to HTTP and then go again to TFTP, and now you can see r1-confg file on the server. Restore the running configuration file to the router. Erase the startup config file on the router. Okay, go to the console on PCA. Erase startup-config. Enter, confirm, enter. Very good. Reload the router, reload, enter, enter. Would you like to enter initial configuration dialog? Answer no, enter, press return, enter. Okay, first verify, enable, show running config. Okay, the host name is the default, only router, no passwords, gigabit interfaces, no configurations, shutdown, shutdown, no passwords online. The device is erased and configure gigabit 01 interface on the router with an IP address 192.168.1.1. Configure terminal interface gigabit 001 IP address 192.168.1.1. Remember subnet mask 24.255.255.255.0. No shutdown. Enter, enter. Okay, and verify connectivity between router and PCA. Okay, and ping the TFTP server from router R1, ping the TFTP server, but wait here to green indicator, the green triangle. Okay. Now it's green, and go to terminal and ping from router to TFTP server. TFTP server is 1.3. Success. Use the copy command to transfer the running config file from the TFTP server to the router. Use the running config as the destination. Okay, copy from TFTP server the source to the running-config is the destination, the running config on the router. Enter. IP address of the server 192.168.1.3. Enter. Source file name. Remember the file name is r1-comg. Case sensitive. r1-comg. Enter. Destination running config. Very good. Enter. Success. Okay. Very good. Verify. Show running-config. The host name is R1. Enable secret password. Okay. No IP domain lookup. Interface gigabit 001 configured with IP address. Banner and passwords on lines. Very good. Backup and restore configurations using router flash memory. Current generation Cisco routers do not have internal flash memory. The flash memory for this router uses compact flash CF memory. The use of compact flash memory allows for more available flash memory and easier upgrades without the need to open the router case. Besides storing the necessary files such as iOS images, the compact flash memory can store other files, such as a copy of the running configuration. In part 5, you will create a backup copy of the running configuration file and save it on the USB memory on the router. If the router does not use compact flash, the router may not have enough flash memory for storing the backup copy running configuration file. Display the router file systems. The show file systems command displays the available file systems on the router. The flash 0 file system is the default file system on this router as indicated by the asterisk. The flash 0 file system can also be referenced using the name flash. The total size of the flash 0 is approximately 7 GB with about 6 GB available. Current flash 0 and NVRAM are the only available file systems. Okay, show file systems. There are two available file systems, okay, two flash and NVRAM, two available file systems. The first is the default, the asterisk, okay, the asterisk symbol is the default file system with about 3 GB of size and free space about 2 GB and is flash. Another file system available is NVRAM with about 20 kilobytes of size. And where is the startup config file located? The startup config file is located on NVRAM, non-volatile RAM. Verify there is at least 1 megabyte of free space. If there is not enough space in the flash memory, please contact your instructor for further instructions. You can determine the size of flash memory and space available using the show flash or dir flash command at the privilege exec prompt. Okay, now you can see here the size and the available free space. Copy the router running configuration to flash. A file can be copied to a flash using the copy command at the privilege exec prompt. In this example, the file is copied to flash 0 because there is only one flash drive available as displayed in the previous step, and it is also the default file system. The R1 running config backup file is used as the file name for the backup running configuration file. Remember that file names are case sensitive in the iOS file system. Copy the running configuration to flash memory. Copy running config to flash. Okay. Copy. The source is running-config and the destination is flash column. Enter. The destination is by default running config, but use this name, this R1 running config backup. R1-running-config-backup. Okay, enter. Very good. Use dir command to verify. Okay, dir flash column, enter. Okay, this is the file, R1 running config backup. This is the iOS image, and these are another files. And use the more command to view the running config file in flash memory. Examine the file output and scroll to the interface section. Notice the no shutdown command is not included with the gigabit 01. The interface is shut down when this file is used to update the running configuration of the router. Okay, use more command to review the file. Okay, more on flash the file r1 running config backup. R1 running config backup. Enter. And you can see the contents of the file: hostname, enable secret, space, IP domain lookup, gigabit 001 configuration, banner, and passwords on lines. Okay. Erase the startup configuration and reload the router. Erase startup dash config dash, enter, enter, and reload, enter. System configuration has been modified. Save? No. Enter, enter. Would you like to enter initial configuration dialog? No. Enter, enter. Verify, enable, show running dash config. Enter. Hostname by default router, no passwords, gigabit 001, shut down, no IP address, no passwords on lines. Very good. Device is erased. Copy the saved running configuration file from flash to update the running config. Copy the source is flash memory. Okay, the source is the file on flash and the destination is running config. But first verify, show flash column, enter. Okay, this is the file r1 running config backup, the iOS image, and copy from flash column r1 dash running dash config backup. Okay, dash backup, and the destination is running dash config. Enter. No such file or directory. Okay, and try the following. Copy, copy, the source is flash and destination is running config. Enter. Source file name. Use this the file on flash r1 case sensitive r1 running dash config dash backup. Enter. Destination file is running config. Very good. Enter. Enter. Okay, and verify. Show running dash config. Host name is r1. Enable secret is class. Gigabit 001 with IP address configured with is shut down. Banner message of the day. Passwords on lines. The show IP interface brief command to view the status of the interfaces. The interface gigabit 001 was not enabled when the running configuration was updated because it is administratively down. Show IP interface brief. Show IP interface brief. Okay, gigabit 001 IP address, administratively down, protocol down. The interface can be enabled using the no shutdown command in the interface configuration mode on the router. Configure terminal interface gigabit 001. No shutdown. Enter. Another option is to add the no shutdown command for the gigabit 001 interface to the saved file before updating the router running configuration file. This will be done in part 5 using a saved file on a USB flash drive. Okay, now end show IP interface brief and gigabit 001 status up protocol up. Optional, use a USB drive to backup and restore the running configuration. Okay, this is not possible on Packet Tracer because you cannot insert USB drive on routers. Okay, go to R1, zoom in. This is the physical view, and this is the USB interface. So you can connect here the USB drive, but it's not possible on Packet Tracer. But anyway, insert the USB flash drive into USB port. Notice the message on the terminal when inserting the USB flash drive. Device USB 0 added. Verify. USB is a new file system with, you can see, with show file systems command. Copy the running configuration file to the USB flash drive. Copy running config to USB. The source is running config, the destination, the USB. And use this name, running R1 running config backup.txt. This is the file on the USB flash drive, dear USB 0, and you will see the file is this, R1 running config backup.txt. Erase the startup config and reload the router. Erase the startup config and reload the router and modify the saved file. Remove the USB from the router. Device USB 0, remove it. Insert the USB into USB port of the PC. Modify the file using a text editor. The no shutdown command is added to gigabit 001 interface. Save the file as a plain text file on the USB flash drive. Okay, add the no shutdown command on interface gigabit 001. Remove the USB flash drive from the PC. Restore the running configuration file to the router. Okay, insert the USB flash drive into a USB port on the router. Device USB 0 added. Dir to verify on USB R1 running config backup.txt. Copy the running configuration file to the router. Copy the source is USB, and on USB this file R1 running config backup.txt, and the destination is running config. Verify gigabit 01 interface is enabled. Show IP interface brief. Gigabit 001 status up protocol up. The gigabit 01 interface is enabled because the modified running configuration included the no shutdown command. Reflection questions. What command do you use to copy a file from the flash to a USB drive? Okay, go to terminal, and the command is copy from flash to USB 0 or USB flash 0. What command do you use to copy a file from USB flash drive to a TFTP server? Okay, in this case, the source is copy from USB 0 column to TFTP server column. Source USB TFTP the destination, or USB flash 0 to TFTP. Thank you.